Section 5.3 is on polynomial functions. A polynomial in one variable is a polynomial that has only one variable, usually x. Its exponents are in descending order, so that's from the largest exponent down to the smallest. The leading coefficient is the coefficient of the first term, and its degree is the greatest exponent. So here's a couple examples. It says state the degree and leading coefficient of the polynomial in one variable. If it is not a polynomial in one variable, state why. Example number 1 is negative 3x to the fourth plus 5x squared minus 1. This is a polynomial in one variable because it only has x's in it. Its degree, remember, is the highest value, the highest exponent, so in this case the degree of this polynomial is 4. And its leading coefficient is the coefficient in front of the highest power of x, and that would be negative 3. Its leading coefficient is negative 3, since there's a negative 3 in front of x to the fourth. Example number 2, 5x squared minus 6xy minus 2. This is actually not a polynomial in one variable because it has both an x and a y. So not a polynomial in one variable, and that's because it has both an x and a y in it. Now, a polynomial function is a continuous function that's represented by a polynomial equation in one variable. For example, the function f of x equals x cubed plus 2x squared minus 5x plus 1. The stuff to the right of the equal sign is a polynomial in one variable, and it's written as a function. So to evaluate a polynomial function, we're going to plug in the given expression for x. Let's take a look at a couple examples here. So this says find p of negative 4 if p of x is negative 2x cubed plus 5x squared minus 3. Now, don't be thrown off by this p. I know most of the time we see f of x, but p, sometimes they use that if they're talking about like a polynomial function. So in order to evaluate p of negative 4, what I do is I take this negative 4 and I just plug it into here for x in each case, and then evaluate and see what the number is. So that's going to give me negative 2 times negative 4 to the third power plus 5 times negative 4 squared minus 3. Now we just PEMDAS this. So negative 2 times negative 4 to the third power is actually a negative 64, plus 5 times negative 4 squared is 16, minus 3. This gives me 128 plus 80 minus 3. So we can say that p of negative 4 is equal to 205. So in other words, in this polynomial function here, when I put negative 4 in for x, I get 205. Here's one that's a little more complicated. Now we're using g of x instead of f of x or p of x, and it's asking us to find g of 5a minus 2 plus 3 times g of 2a if g of x is x squared minus 5x plus 8. So what this means is I'm really going to kind of treat this as two separate problems. I'm going to take 5a minus 2 and plug that into g of x and figure out what that is. Plug 2a into g of x and then multiply it by this 3. And then I'm going to take those two expressions and add them together. So I think I'll do each one of these separately. So let's do g of 5a minus 2 first. So that means that wherever I see an x, I'm going to plug in 5a minus 2. So that's 5a minus 2 squared minus 5 times 5a minus 2 plus 8. Simplifying that, I'll get 25a squared. And then remember, this has to actually be FOILed. And I'll skip showing the work there. Okay, so that's what that FOILs out into. And then distribute the negative 5 minus 25a plus 10 plus 8. And all of that will simplify into 25a squared minus 45a plus 22. Okay, so that's just the first part of this here. That's just g of 5a minus 2. Now I need to find 3 times g of 2a. So 3 times g of 2a is the same as saying 3 times the quantity. Now I'm going to plug 2a in for x. 2a squared minus 5 times 2a plus 8. And then let's PEMDAS that. So 3 times 2a squared is actually 4a squared minus 10a plus 8, or 12a squared minus 30a plus 24. So now that I know what g of 5a minus 2 is, and 3 times g of 2a, to get my final answer I need to add those together. So g of 5a minus 2 plus 3 times g of 2a is going to be what g of 5a minus 2 is, 25a squared minus 45a plus 22, plus what 3 times g of 2a is, which is 12a squared minus 30a plus 24. And then when I combine like terms, I'm going to get 37a squared minus 75a plus 46. And I know that looks like a lot of work, but it's actually very straightforward. The key, I think, is going to be to being neat and doing each part one at a time. Now, graphs of polynomial functions. Let's take a look at this. And this is a little chart from your textbook. So the important thing here is that the degree of the function, in other words, the biggest exponent in the function, is the maximum number of times that that function can cross the x-axis when it's graphed. So a constant function has a degree of 0. So this would be something like f of x equals 3, which is the same as y equals 3. It's a horizontal line, and the number represents where it crosses the y-axis. This will never cross the x-axis unless, of course, it's the function, I guess, f of x equals 0, which would be the x-axis. A linear function has a degree of 1. Remember, a linear function is in the form y equals mx plus b. So something like y equals 3x plus 2. The exponent on x is 1, so it only crosses the x-axis in one spot. A quadratic function is going to have an x squared in it, so the maximum number of times it can cross the x-axis is 2. And if you'll remember from the last chapter, sometimes we saw quadratic functions that just touched the x-axis in one spot, that had only one solution, or maybe it never crossed the x-axis at all, in which case it had no real solution. But the maximum number of times that a quadratic function can cross the x-axis is 2. A cubic function can cross it at most 3 places. A quartic function, so that would be something like an x to the 4th, can cross it in 4 places. A quintic function, so degree of 5, so something like x to the 5th, can cross the x-axis in at most 5 places. And I don't know what they call it if you go beyond 5 degrees. So end behavior. This is kind of a little bit of a difficult concept to understand, but end behavior is basically what is happening at each of the arrows. What y is doing as x increases or decreases. As x gets bigger, is y increasing or decreasing? As x gets smaller, is y increasing or decreasing? And here's a chart from your textbook. It has a lot of interesting information on it, but just to basically go over this here. Let's see, did we talk about? Yeah, even and odd degree functions. We'll talk about that in the next slide here. But basically, let's take a look at this graph here. So as x gets bigger, so as we move along the x-axis, as x gets bigger, y gets bigger. So as x increases, as x approaches positive infinity, y approaches positive infinity. And as we go in this direction, as x approaches negative infinity, y approaches positive infinity. As x gets smaller, y gets larger. In this graph here, as x gets larger, y gets larger. So we say as x approaches positive infinity, so too does f of x. And as x gets smaller, so too does y. So as x approaches negative infinity, y approaches negative infinity. I'm not going to walk through each one of these, but basically the idea is that you need to figure out what is y doing as x gets larger and as x gets smaller. And we'll take a look at a couple examples of this. An even degree function is a function whose degree is an even number. It will have either 0 or an even number of real zeros, and the arrows always go in the same direction. Let's take a look at this chart out of the book here. So here, these are both even degree polynomials. I'm not sure what this one would be represented by, but notice that the arrows are going in the same direction. They're both going down, so this would make it an even function, and it has no real zeros. It never crosses the x-axis. This is actually a quartic function, okay? It is an even degree function because both arrows are going down, and both arrows are going in the same direction, I should say, and it crosses the x-axis in 4 places. And actually, if it kind of went like this and then in the middle here didn't quite go down far enough, that would still be a quartic function or an even degree polynomial. It would only have 2 real zeros though. Excuse me. An odd degree function is a function whose degree is an odd number. So this would be something like with an x to the 5th or an x to the 3rd. It will always have an odd number of real zeros, and the arrows at the ends go in opposite directions. So here's a cubic function here, so like an x to the 3rd power. You'll notice that this arrow is going down and this arrow is going up, and it has 3 real zeros. Here's another cubic function, okay, but it only has 1 real zero. Notice that it doesn't quite go up high enough right here to go past the x-axis. And this has 1 real zero, and because the arrows are going in opposite directions, it's an odd degree polynomial. So let's take a look at a couple examples here. For each graph, describe its end behavior and state whether it's an odd or even function, and then state the number of real zeros. So for this one here, we have this pink line. Let's see, so here's how I like to write it, as x approaches positive infinity. In other words, as x is getting larger, my f of x is getting smaller. It's going down. So f of x approaches negative infinity. So as x gets larger, y gets smaller. Now I need to talk about what happens when x gets smaller. So as x approaches negative infinity, what does f of x do? Well, that also goes down. So f of x also approaches negative infinity. This is going to be an even function because both of the arrows are going in the same direction. They're both going down. And this actually has 4 real zeros. And remember, those are the places where it crosses the x-axis. So right at these points right here, those are the 4 real zeros that it has. Okay, let's take a look at this function here that kind of goes down, doesn't quite get to the x-axis, and then heads down this way. So as x approaches positive infinity, so as my x gets larger, my y is getting smaller. F of x approaches negative infinity. And then as x approaches negative infinity, as x gets smaller, notice my arrow is going up, so f of x approaches positive infinity. Okay. This is an odd function because the arrows are going in opposite directions. This one's going down, that one's going up, and this function has only 1 real zero because it only crosses the x-axis in one spot.